Hello, everybody. Welcome to the At-Scale event on AI and data. I'm Krishna Gade. I'm the founder CEO of Fiddler AI. We are an enterprise AI observability startup in the Bay Area working towards the mission of building trust in AI. Today, I'm here to talk about agentic observability, why it's very important to think about, observing LLM apps to make them more reliable, more trustworthy, and more debuggable. And and this is basically an important aspect for many teams looking to deploy AI agents to production. With that, I'd like to give you, brief context of where the world is moving. Today, the nature of software itself is changing. In the past few decades, we've actually built, applications in the traditional sense, where they're largely code-based with, predefined logic, more deterministic and largely static in their behavior. Now we are entering into the world of agentic AI, agentic applications that are fundamentally model based and non deterministic in nature and highly dependent on the data that is supplied to them. This is a new kind of application that we're building, and lots of teams are transforming the existing software into agentic based applications. They're either layering on agentic skins on top of their existing software solutions. But the core problem is, how do you make sure these agentic applications are reliable and trustworthy? And that's where the observability comes in. Let's dive into the world of agents and workflows. What is an agent? Agent at the end of the day is a system that is dependent on LLM, that is making dynamic decisions, directing the workflow of how the sequence of steps that it's doing, solving very complex tasks. We are looking at teams that are, agentifying claims processing workflows, credit risk report generation, customer service, travel, all kinds of complex tasks are being agentified. And then a workflow is essentially a system of, a directed acyclic graph of execution steps. How do you sequence these things? How do you layer on the agentic tasks one after the other? And there are many types of workflows. This is Anthropic is written a great blog about it on various types of workflows. One of the most popular workflows is the prompt chaining workflow. For example, you might have built or used a text to business intelligence application. Behind the scenes, what's happening is it's taking the natural language text that you're entering. So, for example, you might say, what is my overall quarterly sales growth, how are my customers doing, which customers are at risk to churn. All of these queries are behind the scenes implemented as text to SQL, SQL to database queries, and database answers to LLM summaries, so that you can actually see a beautifully coherently written answer come to you. And there are many other types of workflows that have become popular in the last year or so. The routing workflow, where there's a supervisor agent that might route the tasks and kind of distill the task into subtasks into later step of agents to solve them. Or you may have a parallelization workflow that takes the results of these subtasks and aggregates them. Or you may have an evaluator optimizer workflow where you have an agent that is generating the content, the other agent is actually evaluating it. So you have all of these different workflows that are coming together to create this agentic AI. Now, agentic AI, the new reality of it is, it's basically moving LLM applications from a single input, prompt in, response out type of an application that we have been used to in the last couple of years, to a more complex, more goal-directed, multi-step workflow. And it's able to do several things like planning a particular task, acting upon it, even reflecting on the outcomes of it. And then it basically naturally increases the black box complexity of it. Where is this? The failures might be happening. Are they happening because of tool call failures, or a database lookup has not been successful? Because when you're building this agentic workflow, you're not only calling LLMs, you're calling your internal databases, your other external APIs, and failures can happen as these workflows become more complex. So the need of the hour is, as teams, we want to know not just the outcomes of these agents, but why they're successful, why they might be failing. And that's where the observability or monitoring system becomes very important. And the monitoring of these multi-agent workflows is more complex than a simple single agent workflow. So far, a lot of AI observability efforts have been into monitoring and observing single agent workflows. So a good example is a conversational chat where a prompt goes in, it looks up some unstructured data like a policy documentation or some frequently asked questions, comes back with an answer. The question is around, is the answer correct? Is it hallucinating? Is the prompt, is it leaking any private information for me? Now, we are now entering into a world of multi-agent workflows where this a particular question could be like, hey, book me tickets from New York to San Francisco where for a couple of days. I will be in this location. I prefer these type of hotels. And so you sort of provide this context to the agent, and it will spawn itself into many subtasks that come together to execute on this thing and produce the appropriate result. And monitoring such a complex workflow is quite challenging. And for these following reasons, right? So imagine that travel application that I talked about. Here you can see multiple different types of sessions, where users might be indulging in this travel agent, different types of source and destinations, different types of complexities. Based on that, the orchestrator can route that particular task to the various sub-agents. Now, what you want from a monitoring system is to be able to know application level health. Is the routing happening? Are the APIs calls successful? Or if they're retrieving any information from database, are these being successful? And then being able to monitor session level. Is the user journey being successful? Are you actually producing the right outcome for that particular user? And how the agents might be transferring tasks between themselves. Are the chains working properly? And then a particular span, is essentially producing the right result. So this is where the complexity peaks and the need for the agentic performance management comes about. So I'd like to argue that as the nature of software application itself is changing fundamentally, we need to rethink the rules of APM, the rules of how application performance management, the way it was in the APM 1.0, where we were monitoring largely deterministic applications, deterministic software on server failures, latency, and throughput. Now we need to think about the new metrics, new kinds of behaviors that we need to monitor. And I'd like to argue that APM 2.0, the time has arrived, and that's agentic performance management. So an agentic performance management system could look like this, right? Where you have a new kinds of application that is dependent on data, that is interacting with these models, and it is built upon these agentic programmatic frameworks, and you're standing up these agentic workflows to solve these complex tasks. And this new application needs to be observed and needs to be monitored so that it can be deployed at scale. So let's dive into how can one go about building such an agentic observability system, because that's, at the end of the day, we need that to deploy these agents. I'd like to argue that we need to marry two distinct paradigms of monitoring to build such an agentic observability system. One is your traditional application performance management, which talks about infrastructure utilization, your response latencies, your throughputs, to the model performance management that talks about the model behavior, your hallucination detection, your data drift detection, into this new world of agentic performance management, where you can bring these two worlds together to solve this agentic observability problems. So if you go into the more details, such a system would look like where it can track these APM type of metrics, like latency of API calls, reliability of API calls, infrastructure utilization, reliability metrics, latency metrics, and then bring the model observability metrics like hallucination detection, prompt detection attacks, data drift, into building an agentic observability system that provides hierarchical visibility into the workflow, how it's performing, how the various sub-agents are performing. And this creates a system of intelligence where you can track all of your agents, the interactions between those agents, how these sessions are performing, how a particular user journey is happening, and then you can resolve failures very quickly. So let's look at, this new way of agentic observability, how this actually gets built. From a fundamental point of view, there are few concepts we need to sort of think about when building agentic observability. First of all, observability systems that have been kind of externalized when it comes to traditional software need to be internalized in the agentic workflow. There's this concept of reflection where agents themselves, the workflows, agents themselves reason about the outcome of those tasks. They can evaluate what happened, whether the right outcome was reached or not. So this reflection becomes a very fundamental component, like to help you co-observe the workflow. And then how the tool usage is happening, because tool calls can happen because the decisions are being directed by models, and what APIs and tools are being invoked, and why are they being invoked, what plans is the agent trying to draft when it solves a particular task, and then what is the collaboration of these different agents coming together. All of these needs to be monitored. So I'd like to sort of think for all of you to think about the anatomy of what an observed agent would look like. An observed agent would know what is the input that the customer is inputting, or user is inputting, what is the prompt, what's the context being passed to it. So let's talk what's the thought you're starting with. Maybe it's the travel booking task, or maybe it's like a stock purchase task, or some other customer support task. And then what plan is generated? What is like the various level of subtasks that are spawning out of this workflow, and how are they executing? What tool calls are being executed behind the scenes? And then how is like the workflow reflecting on the outcome of the execution, and then any alignment you need to do with like guardrails and controls in place. So you can create this virtuous feedback loop where you have an observed agent that is planning and acting and reflecting and course correcting in its lifetime. And this is fundamentally the new thing when it comes to agentic observability compared to like traditional software observability. And so the way it manifests itself is in new kinds of metrics. For example, you may want to understand how many times reflection was needed, how many iterations of reflection was needed to complete a particular task. That could give an indication of the inner workings of the agentic system. You may want to know the tool execution metrics, what APIs were called, whether they were necessary or not, whether the output of those APIs was parsed correctly or not. How did the workflow planning happen? What other agents were called in this space? What information was sent to these next level agents? Was the context transferred properly? All of this need to be monitored. And then you need to know if like the adjustments and alignments are happened properly, whether the fallback triggers have invoked, whether the guardrails were correctly invoked, and what happened in that sort of processing of that task. And so these are new kinds of metrics that we are talking about to sort of build that agentic observability. So our approach at Fiddler is to think about this agentic workflow as this dynamic system and instrument everything, right? So being able to capture all the action chains, logging every decision, every tool call, and every plan that is drafted, so that you have the map of input, the decision, the output at any stage, with attach it to a trace ID, so you can essentially visualize and reconstruct the graph of execution when you're going to do a root cause analysis. Maybe the failure has happened because of an LLM hallucination. Maybe the failure has happened because of a policy misalignment, or maybe it because of a tool call failure. And being able to know all of this, whether the guardrails have worked in this case, whether they were able to protect the application adequately. And so that's basically how the system works, right? So you collect all of the data, you instrument all of the data, the inputs, the outputs, the trace IDs, and you process the system through these, trust models, the small language models, the large language models as a judge, to produce these different metrics around model-based metrics, agent-level metrics, system-level metrics that can then be, displayed on dashboards that help the users to do root cause analysis to find out problems, and then ensure high level reliability of your agentic applications. So let's actually apply this to that travel application problem. This is actually a live demo of our agentic observability product, where you can see that that sort of a parallelization workflow, which takes your agentic task of booking tickets and hotel reservations and spawns itself in multiple subtasks. You can then look at the hierarchy of the agent. You can see all the different spans, trace through each of the sessions of the users and find out the individual failure points and know whether the problems happen because of model problems, or whether the problem has happened because of the system issues, or or a combination of both. And so at the end of the day, I'd like to argue that production readiness of an agentic application means it has to be observable, which means you can reason about how it's performing. You can have metrics that go beyond just the LLM behavior, but measure its alignment with the policy, the business problem that you're trying to solve. You can have an audit trail of, so you can go and inspect what actually happened. And you can share these insights, to not just the AI engineers, the application engineers, but like to product managers, to business people, to compliance and security folks that want to know how these agents are working behind the scenes. And so with that, I want to sort of end this talk with a few hot takes. Number one, the logs and metrics that we are used to in the traditional observability system, to me, are mostly dead. Yes, we will instrument the agentic workflows, we collect all of the information, but the way we observe these agents is fundamentally different. I'd like to call this runtime semantic tracing. We are trying to understand the why, how things are working behind the scenes with these agentic workflows, and how the models and systems are coming together to operate on the tasks that users are making these agents solve. Number two, this is actually a very, very fundamental difference, is agentic observability is not an externalized system like we are used to with the traditional APM tools that collect all the logs and give you a dashboard of different server utilization latency metrics. Agentic observability is co-observing the agents along with the cognitive processes that the agents are relying on, the large language models that are powering these agents in most places, so that we are trying to do a live intervention if possible, so that goal is to make sure that the agentic workflow is performing the right task. And so this co-observing nature of it makes reflection, this new behavior of agentic workflows, the core component of logging. And finally, agentic failures are not necessarily bugs, they're behaviors. So our goal as developers is to make sure that the agents are aligned to the policy or the business problems that we are trying to solve. And we want to make sure that the misalignments we are able to catch, we want to understand why the misalignments are happening in the first place and try to see if we can course correct. And this is a very, very fascinating problem, because until now, live intervention was not possible in software, right? So if you had hot shot in a database, or a server is going down, you had very limited capabilities to sort of automatically do self-healing. Yes, we made a lot of progress in self-healing in distributed systems, but with agentic workflows, we actually can combine live intervention with observability and try to make observability more actionable. And I think this makes agentic observability very different compared to the traditional observability. With that, I'd like to sort of leave a call to action to everybody thinking about or developing agentic applications to consider agentic observability. It will help you make your LLM apps more reliable, more debuggable, more understandable. And at the end of the day, you will be able to ship a much more trustworthy AI application to your end customers. Thank you so much for listening to my talk. Have a nice day.